Good morning. Welcome back to the course Product Design and Manufacturing. So herein we are discussing how to design a product, how to develop a product and how to manufacture a product, starting from the very basic idea to have the final prototype and then testing. And further we will also discuss how to market the product, what is the how to manage the competitiveness, market competitiveness, benchmarking and these things. And in this specific lecture, I am trying to focus on the plant layout planning. Plant layout is an important factor in product manufacturing. Because the cost of the product is very much dependent upon the time. Cost is proportional to the time that is taken by that product to get manufactured. So this time is very important factor in a factory. In a factory, material handling is there. The product has certain complex characteristics. Certain products are very complex, certain products are simple to manufacture. So there needs to be some specific arrangement of the equipments and tools and the movement of workers, material handling, so that the product time is minimum and the cost is also very much optimal. So I will try to cover an introduction to plant layout. So why plant layout study is important, then we will discuss certain factors, those affect the plant layout, then the types of plant layout, and we will see the advantages and disadvantages of all these: process layout, product layout, fixed position layout, combination layout, cellular layout and some other miscellaneous layouts. So how do we define a plant layout? Plant layout is the most effective physical arrangement either existing or in plans of industrial facilities. Industrial facilities. So it has to be most effective. How it can be most effective? We will see. Now it is arrangement of machines and equipment, and it considers certain all the M's of management. There are 5 M's in management. 5 M's of management are money, men, materials, machines and methods. So the plant layout is an arrangement of machines or the processing equipments and service departments to achieve the greatest coordination between the 4 M's, these 4 M's, so as we could have lesser investment, lesser money is used here. So these 4 M's are more of focus in plant layout study. So layout problems are fundamental to every type of organization or enterprise and all kind of undertakings. The adequacy of layout affects the efficiency of subsequent operations. The layout study is an engineering study used to analyze different physical configuration of a manufacturing plant here. By physical configuration, I mean the plant setup. For example, this is the area where my factory is to be set. I need to divide into the certain sections. I need to see where we have the entry, where we have the exit, and we need to put certain machines in here. So this is a kind of a layout. Now these are the fixed equipment. Then we have material handling. The workers would keep moving between these machines. So this one unit is called unit process or a unit manufacturing process. So these are physical configurations: unit process, material handling equipment, then consumable tools. Also I can put workers here. So these are all physical configurations. Now next is, why do we need a plant layout study? Many situations give rise to the problem of plant layout. Two plants having similar operations may not have identical layout here. For example, both of the plants are producing similar kind of product, but the layout might be different. And because the nature of the process and management caliber, how well is management able to take the decision about the plant layout here is also a factor here. So the plant layout study is necessary because of following factors. There are design changes sometimes in the product, and because of the design changes, sometimes some new equipment or new tool, some new tool or new process is to be added, or some obsolete, better to use not obsolete or not in use process is might also be there. Then sometimes the enterprise think of expansion. Every company, every industry, as we've seen in the physical world, is trying to expand. The automobile industry is trying to expand. The competitiveness in the market is too high these days. A product segment for a software, if I say the life of a software is not more than 6 months. For the mobiles, the lifespan of the mobile phone, a new segment of the mobile phone or a new class of the mobile phone would get obsolete or would get outdated because of the new products coming in the market in maybe 6 months. So there are numerous competitors. China is coming into play. China is taking the market share very fast. So new products are there and enterprise are trying to expand. So a plant layout has to be made in such a way that the expansion is also possible. If there is some layout, we'll discuss about the layout. For example, this is U kind of layout. It could be expanded, or we could be able to put some more machines in there. So this is one of the factor here. Then there is variation in the size of the departments. Sometimes the department size vary. For example, in recent years, the R&D is taking place very fast in automobile manufacturing, in mobile manufacturing, and I would rather say in almost all the products, R&D department is playing very big role. So that is why the variation of the size of the department, R&D department would become bigger. R&D department. And if some new product is to be added into the line, that might also need the change in the plant layout. Some new department is to be added sometimes, and even if a new plant is to be set up, the plant layout has to be studied. So next I'd like to discuss a few factors that influence the plant layout. The major factors that influence the plant layout are processing time of the product, product physical characteristics, intricacy of the product, production volume of the product. Now, what is processing time? It is actually the material handling time. Material handling time. So when I say a processing time, or product manufacturing time, if this is the time span, if I divide it into various parts, this is setup, this is actual operation, and this is dispatch, and here we have the receiving from the previous unit. Now here setup and operation are the attributes of my unit process. For example, if there is a milling machine, or if I put it there is a lathe machine, setup would be made here, or operation or processing would be done here only, and this receiving and delivering out is done by material handling systems. These are done by material handling systems. So this is very much dependent upon this time, material handling time is very much dependent upon the kind of plant layout, the design of our plant. So it has a significant proportion of total time of manufacturing, and any reduction in handling time of the product may result in great productivity improvement. So that is why processing time is one of the important factor that influence the plant layout. Product physical characteristics. By physical characteristics, I would say weight of the product, volume of the product. Here by volume I do not mean the production volume, volume means the physical size of the product, and the mobility of the product, that how what is the ease of the product movement, could we move the product, or does it have to be made in a fixed position. So if the final product is quite heavy or difficult to handle, involving costly material handling equipment and a large amount of labor, important consideration will be to amount the product minimum possible, to give minimum movement to the product. For example, in aircraft manufacturing, we will use fixed position layout. The product, handling the product, moving the aircraft through a conveyor line would be very much expensive, and even the space that is required would be very large. The movement energy that would be consumed in moving the conveyor belt would be very high. For in that case, the mobility of the product suggests that it has to be fixed position layout here. Now next is the intricacy of the product. Now if the product is made of very large number of components, then large number of people may be employed for the handling the movement of these parts from shop to shop, or from machine to machine, or one assembly point to another. Then the product layout has to be accordingly. By intricacy I would means large number of sub assemblies or components. So in this case I can say in automobile manufacturing, the car manufacturing is being carried out on conveyor belts, and it has large number of parts involved. The large labor is involved in there. The labor, what do? Their labor is there in fixed position. They just do their job. For example, one guy is doing just fixing the side mirrors. He will keep on fixing the side mirrors and do the same things on the same side. If he is putting the right side mirror on, he also putting the right side maybe lid or maybe the wheel cover kind of things on into automobile. Next is production volume of the product. The production volume, here I mean the quantity of the product. The extent to which process tends towards mass production, that is mass production. If it is volume is very high, it will be mass production. If the volume is low, we can call it batch production. Now with the use of automatic machines in industry for adopting mass production system of manufacturing, the volume of production will increase. in view of high production output, larger percentage of manual labor would be engaged in transporting the output unless the layout is good. So in this case, mass production, to reduce labor or human movement, the layout has to be designed accordingly. What layout can we use for this? We will see in the forthcoming slides of this lecture. Now let us come to the types of plant layout. According to the type of industry and rate of production, different types of layouts can be selected from the following. Number 1 is process or functional layout. Number 2 is product or line layout. Number 3 is fixed position layout. Then we have combination of these two, process and product, it is known as combination layout. Then we have cellular layout, that has also certain advantages, we will see here. Then some other kinds of miscellaneous layout we will see. So let us come to the process or functional layout first. Process layout are discovered essentially in workshops, firms that deliver altered low volume items that may require distinctive preparing necessities and arrangement of operations. By low volume items, if I say low volume, as I just mentioned, that means it is a batch production. So what is process layout? It means the similar kind of processes are arranged in one section of a factory. The similar kind of operations are carried out in one section. For example, one section can do all the lathe, one section can have all the lathe machines, another section can have all the milling machines, and the other section can have all the drilling machines, and finally grinding machines and inspection. Final one section would be of inspection. In this case, the product, it is having certain sequence of operations, the product which that is to be carried out on a product. What is has to be done? For example, the first operation is milling, second is drilling, third is grinding, and then is inspection. So what happens? This milling operation would be carried out in the milling section only. We will see the kind of layout here. So this is a material that is receiving by a warehouse. So here we have only drilling presses. Here we have punch presses. Here we have lathes. Here we have grinders. Here we have finished goods. Here we have inspection. Here we have shipping warehouse. So let me say in place of milling, let me say punch. First I receive my product here. In case of this specific batch which I have I am trying to put here, I say punching. So my product would first be received here, then second operation is drilling, third operation here is grinding, fourth operation is inspection, and the final shipping. So this red arrow path is for my one product here. For another batch, I could have, this is case 1. I can either have second product or product 2, I would say. In that case, let me say I have first process as drilling, second process as punching, third process as some turning or some step turning, that is lathe operation is required, lathe machine is required here, then grinding and inspection. So in this case, it will follow a different path. Once this batch is over, the second batch would come into play and that will follow this path. From the receiving end, we will first receive the parts to the drilling presses section, and This will go to punching, then step turning would be carried on lathe machines, then grinding, then inspection and again, and then final shipment. So this is my green path shows second badge here. What do you think? If we have mass production, is it good to have this kind of layout? Would this be beneficial? Or if we have some very big equipment, very big product, I would say, manufacturing of a ship, manufacturing of aircraft, could we move in this way? Could we move that? No. So this kind of layout is not fit for mass production. Now process layouts are office arrangements in which operations of a comparative sort of or capacity are assembled together. In that capacity, once in a while are alluded as utilitarian formats, once in a while only. So here the objective is to process products or give benefits that include an assortment of handling prerequisites, that is here requirements here. The example would be a machine shop. As we have seen, this is an example of a machine shop here. So a machine shop could have various other machines, like we have punch press, drill press, lathe, grinders, finished goods, inspection, shipping warehouse, that is the warehouse only. We cannot have hydraulic presses, we can have CNC machines, NC section, CNC section, and certain similar kind of sections here. Now along these lines, offices that are designed by a singular capacity or procedures have a process format. This kind of format gives the firm the flexibility expected to deal with an assortment of routes and process requirements. Administrations that use process layout incorporate, for example, other than the manufacturing, in clinics, in banks, you would say in banks cash receiving section is there, manager is on one side and inquiries on the other side. All these sections are divided. In clinics also we have the different labs set into different sections. We have all the laboratory testing into one section only, that is the testing area only. On one section we have OPD, on one section we have surgery. So that is the way these systems are designed. So similarly, when we go to an auto repair shop, or in libraries also, the books are arranged according to the sections here. Okay, I can even put the institutes or universities. You have mechanical department, chemical department, all engineering departments have different sections, and in that is a kind of an institute is a kind of a system of systems. So here the full system is an institute, the smaller systems are its department, its respective departments, and this smaller system even has certain subsystems into it. So subsystems are in mechanical engineering department, we have design department, we have manufacturing department, we have thermal department, we have solid mechanics thing, and all those are divided accordingly. So improving process layout involves minimization of transportation. That is, I am again putting material handling minimization. So how this could be done? To have minimum distance between the frequent moving, and this obviously lead to lesser time. So in this case, because the distance is minimum, the time is less, the transportation cost would be less. specifically transportation. Or process or functional layout. Here we have put the functional word as well here, as we have very well known now in value engineering concept what is function. So this is one function, drilling. This is the second function, punching. Third function is turning here. Fourth function is grinding. Fifth function is just finishing the goods. This is another function. So it is divided accordingly to the function groups. Now there are certain advantages of process layout. Number one is flexibility. Flexibility is because it is a batch production. So any product, most of the product can be put into this. So as I have just discussed, in why plants layout study is required, the variation in size of department, in product design changes or some new product is to be added, this process layout offers best flexibility, because we'll see in product layout or line layout that putting even one machine into the line would demand for relocation of all other machines. So the flexibility is very high here. Then is the cost. In some cases, the general purpose equipment might be less expensive to buy and less exorbitant and simpler to maintain. This is in comparison to the special purpose equipment. The special purpose equipment is used generally for mass production. For example, general purpose equipment are these only: the lathe, milling, drilling, grinding, all these machines. And for the special purpose machine is, one machine is known as bolt maker. It will just take the round rod as its input. It will first form the rod into a hexagonal shape after passing it to certain passes, and after that it will cut that rod. So this rod, which is now transformed into a hexagonal bar. Now this bar would be cut according to the size of the bolt required. Then the machining would be carried out, turning would be carried out, and after turning the threading would be carried out. The mechanical people would more appreciate this process. So these are known as special purpose equipment. Now next advantage is motivation. Here the motivation is the worker motivation to work here. The workers in this kind of design, this kind of layout design, will presumably have the capacity to play out and the assortment of assignments to on numerous machines. So the boredom is absent. So because they would have to keep on moving, the monotonous kind of job is not absent here. This monotonous job or monotonous nature of job is not present here. So this brings some interest into work. Next is system protection. Since there are various machine accessible, process layouts does not exhibit much equipment failure, because even if one machine fails here, in this for example I have here 5 numbers of different processes, and if one is not working, other 4 can do the purpose. There are certain disadvantages also associated with process layout. Number one is availability. The hardware use rates in process layout are often as possible low. Machines usage is dependent upon a variety of output requirements. So here by availability, I could even say the capacity utilization. For example, at certain point of time, we have 10 badges or 10 kind of production line, and at some other point of time, we have only 2 badges. In this case, the capacity utilization would be low. In this case, the factory would be running out of capacity here sometimes. So the capacity utilization is a factor here. Next is cost. In the event that batch processing is utilized, in-process inventory expenses could be high and setups are more frequent. In-process inventory here, what we have, for example, a drill press is taking 50 seconds for processing, for doing one job. Now this one is taking, for example, 150 seconds. So what is happening? 100 minus 150 minus 50, 100 seconds is the waiting time for one job here, and here we will have stacking. Here we will have to locate a buffer to store. So in process inventory here is high, and inventory carrying cost, when we talk about EOQ, that is economic order quantity, we have two factors here, two major factors here: inventory carrying cost, or also it is known as holding cost, and the setup cost, that is making an order. So in this case the inventory carrying cost is high. In this case setups are more frequent. This setup is not the order setup of inventory, not this setup. This setup is the machine setup. To for example, in a single lathe, if I am trying to do step turning first, then next process on a second job I have to do taper turning. I have to then fix the job and then do setting of my tool post accordingly that the taper turning is carried out. So that setup is very much frequent here. That also involves some time. So material handling is slower and more wasteful here. The span of supervision is small because of occupation complexities. Routing, setup, and so on. These complexities, these occupations all are carried out. Moreover, in the sort of design, bookkeeping, stock control, and buying for the most of the part are exceedingly included. So this is all accountable, this is all management's work. Next is perplexity. Always showing signs of change plans and routing make rearranging of process necessities more troublesome. So that is why some complexity comes into play. So next is product or line layout. It is also known as flow line. Product layouts are found in flow shops, that is monotonous, get together and process or ceaseless stream ventures. In a product layout, assets are organized consecutively in view of the directing of items. Here by assets I mean the machines or equipment. So flow shops produce high volume, high standardized products. High standardized products. So these are the processes here are monotonous or repetitive. So in principle, this consecutive layout enables the whole procedure to be laid out in a straight line, which now and again might be completely devoted to the creation of just a single item or item form. So in one line, this is also known as flow line, the machines are set according to the requirement of the product. For example, this is product 1. So this is operation 1, operation 2, operation 3. Whatever would be the sequence of operation for this product, this arrangement would be made. What we can see here is, because it is made according to the product, this product would be manufactured fast. That time material handling would be less in comparison to the process layout. But this is good only if mass production is carried out, only if the product 1 is having very large quantity to be manufactured. large quantity, because you see these machines, 5 machines, are dedicated to only one product, so it has to be done wisely. The stream of line would be then able to be subdivided with the goal that work and gear are used easily all through the operation. So here work and gear means the workers and equipment or machines. Now there are two kinds of lines that are utilized as a part of item formats: paced and unpaced. So what is there in paced lines? The product is attached, product is fixed to the conveyor belt. The product is fixed here, and the machines or the workers whoever has to carry this operation would do its operation whenever the product is flowing in this path. So this can utilize the type of transport that moves yield along at a persistent rate with the goal that workers can perform operations on the item as it passes by. For longer working circumstances, the worker may need to stroll close to the work as it moves until that point he or she is done. So what happens, as the work is fixed here, we cannot take off this product from the conveyor belt. So what if some operation has to be done here, that is to be done by worker 1 only. If the worker 1 has to do this operation, he has to move here or stroll here to do this operation with worker 5 and then again come back to its position. So then he can stroll back to his own position, home workstation, to start dealing with another part here. Oh, this is paced flow line. Next is unpaced line. In an unpaced line, the laborers develop lines between workstations to permit variable workplace. So what happens in unpaced line? The product is not fixed on the conveyor. It is not fixed. When I use word product here, by product I would say my work or my workpiece. It is not the end product here. Here would have end product or final product. So what is happening here? He can take off this piece, he can take off this workpiece and take it to another line to do this operation. He can take it off. So this kind of line does not function admirably with an expensive, cumbersome items, in light of the fact that an excess of storage room might be required. In this case, some storage might be required here. Storage. It is hard to adjust an outrageous assortment of yield rates without critical sit out of gear time. Now there is a method known as line balancing or assembly line balancing that can be utilized to gather the individual assignments performed into the workstations so that there will be a sensible adjust of work among the workstations. So what is actually line balancing? Line balancing is the assignment of tasks. It is assignment of tasks to workstations in a way that all workstations have approximately equal time requirements. Assignment of tasks to workstations to ensure that all workstations have equal or similar or close time requirements. What will this do? This will reduce the idle time of the machines. So this is line balancing. So line balancing, the product layout efficiency is frequently improved using line balancing. This minimizes the amount of time that some workstations are idle. So this minimize time. Better to say minimize idle time. So this idle time is due to the workpieces which are waiting on parts from an upstream process and to avoid building up an inventory queue in front of downstream process. The line balancing is done in product layout. This is a kind of a product layout here. The raw material is coming in. We have one process: turning, drilling, milling, then grinding, boring, reaming, inspection and packaging. And the product 1 is out. And the second process is, second product is, the raw material is coming in, certain processes are being carried out: casting, grinding, turning, drilling, milling, painting, inspection, packaging, and then product 2 is out. Again recalling, this is mass production or high volume production. So there are certain advantages of product or line layout. The yield or the output, the product layouts can create vast volumes of items. The yield is too high. The cost, unit cost is low because of the high volume. The unit cost is the cost of the product. Work specialization brings about condensed preparing time and cost. Preparing time is reduced because there are less setups, less frequent setups in here. I will put it here. Less frequent setups and more extensive traverse of supervision likewise diminishes work cost. Extensive supervision is carried out by the worker here. Now bookkeeping or accounting, purchasing and inventory control are all standard because of mass production. Since routing is all settled here, less supervision is required. Then is availability. There is high level of work and hardware usage. The capacity utilization is high here. Disadvantages: the inspiration or motivation because of monotonous kind of job nature. The framework is the layout characteristic. Division of work can bring about dull or bore redundant occupations that can end up being very distressing. So some fatigue can come. In this case, I am not talking about physical fatigue, that is different, mental fatigue. So for this, certain breaks are, when we talk about the work study and we talk about the method study, when we talk about the efficiency of the worker, it is the skilled workers is compared with the standard worker, and certain breaks are given in between. For example, if there is a 8-hour work shift, certain breaks after every 3 hours or every 2.5 hours is given. So that is why the fatigue can be reduced. Next is adaptability. Product layouts are inflexible and cannot work without much of a stretch react to required system changes, particularly changes in item or process plan. As I have discussed before also, if I need to put one more machine and additional process here, what I have to do? I have to shift all these machine forward to provide a space for another process here. So this flexibility is lesser here. So this is also a disadvantage here. then system assurance. The framework or the product or line layout is in danger from the equipment breakdown or hardware breakdown or non-attendance. Non-attendance means absent of the workers, and downtime because of preventive maintenance. Preventive maintenance whenever, because this is a kind of a series connection. If one equipment fails, this fails implies work is halted, whole process is halted. To make sure that the need of corrective maintenance or breakdown maintenance is not there, preventive maintenance is carried out, but that also consumes time. Preventive maintenance is carried out. For preventive maintenance, this machine has to spare some time for maintenance as well, and during that time operation wouldn't be carried out. So next is fixed position layout. Let me take a break here, and in the second part of this lecture I'll discuss fixed position layout. Then we'll discuss about combination layout. Combination layout is the combination of process and product layout. Where is it beneficial? We'll see. And why do we need combination layout? Then is cellular layout. Cellular layout is very prominent, very widely used in industry these days. We'll see about what is group technologies, what is flexible manufacturing system, certain introduction to this one. So let us meet back in the next part of this lecture. Thank you.